Hello, everyone. Today I'm going to be going over a short video of modeling the solar system. So you're going to have to learn how to create a scale drawing. Um, Ideally, if we were in class, you would use an actual poster board, but here I'm not going to make you go out and get a poster board and do all this stuff. Weird times call for weird innovations, I guess. So I'm just going to have you create the scale of whatever you're doing and for modeling the solar system. And it's basically going to be number four over and over and over again. Because, like I said, you would use a poster board and you would actually draw these things, but I'm just not going to make you do that. Okay, so the common misconception here. Hey, sorry, my cat is getting into things. Um, Common misconception here is how like big and small everything is relative to each other. Hey, stop! My gosh. Okay. Um, sorry about that. Common misconception here is how everything is related to each other, and that's kind of what this whole lab is about. So you can go through the theory. I'm not going to do that because you can read on your own. Here we have different radii and distances. So uh, this is the main table that you're going to refer to. I don't know that this video is going to be super long. I'm just going to explain to you the basic idea and what I want you to do here. On part A, it's the scale of the solar system. I believe I put the if the moon were only 1 pixel link to the lab there. So pull up the web page and basically scroll through it. It's incredibly long, but you can see the vast difference in size of the solar system if the moon were only 1 pixel on your lab. So I'm not going to go over A. You just need to do that and then answer the questions down at the bottom. Um, Here, message one, message two, message three. There's some pretty, I don't know, humorous messages here. Okay, the big thing is right, like B, C, and B and C basically. That's like the big kind of part of the lab. So what you have to do is figure out um, the diameters in B1. You need to figure out the diameters. Remember, up here in the table, it gives you the radius. So you need to figure out the diameter of that. And I'm not going to tell you how to do that. I mean, I will tell you how to do that actually. Diameter is just twice the radius, so that's not too bad. So you need to figure out the diameter of each of these in kilometers, and I give the radius to you in kilometers. And then what you need to do is figure out the diameter in centimeters. And I'm going to tell you right now, let's say that your poster board dimensions are 22 by 28 inches. So let's say let's say the diameter of the sun is 20 inches on the poster board. Okay, the diameter of the sun in kilometers for real is, well, this times 2. All right. So what you need to do, and you can collab with your classmates online or something like that, is you need to figure out how big for every 1 kilometer should be 1 centimeter. So I said draw the sun as if it were 20 inches in diameter. 1 centimeter or 1 inch is 2.5 centimeters. 2.51, I think, something like that. Let me make sure I did that. Inch to centimeter. 2.54, excuse me. So, the diameter of the sun, however big that is, you're going to multiply this 6.96 times 10 to the 5th times 2. However big that is, you have to relate that to centimeters. So, I mean, yeah, to centimeters. So it's 20 inches on the board. This may take some mental gymnastics or something. And in the scale drawing method in comparison to other groups, don't worry about all that. So you're going to have to get a scale factor. 1 kilometer is equal to how many centimeters? Okay. So the sun is the biggest thing on there. So that's basically what your base level is going to be. And all of these are going to be incredibly tiny compared to the sun. I think Jupiter, for like reference, if I remember correctly, is something like maybe, I don't know, like 4 centimeters or something like that. I believe. I could be wrong, but regardless, you're going to have to scale everything down. That's like the crux of the situation here. You'll have to scale everything down. And you're going to have to do it in diameters. So all of this stuff up here, the radius, you're going to have to multiply it by 2, and that's going to be your diameter. Okay. So once you figure that out, and you can make posts on the message boards with your classmates. I'm not gonna tell you how to do scaling, because that's just, it's something you have to. I mean, that's like the point of the lab. Here again is a similar situation, but this time it's the average distance from the sun. So your sun is going to be at 0 centimeters, and everything else is going to be some distance. So we have a poster board that is 22 by 28. So 28 being the long part of the poster board, you're going to have to scale all of these planets between 0 and 28 inches. So you're going to have to convert inches into centimeters here, because we like centimeters in science. So the sun, I'm giving you this now. This is a freebie. The sun is at 0 centimeters. And Pluto is going to be at 70, let's say 71 centimeters, which is about 28 inches. 71.12. That's the amount of inches that's in a centimeter. So everything else, you're going to have to scale down. Okay. So we give you up here, we give you the average distance in kilometers. And Pluto is 5.91 times 10 to the 9th kilometers away. It's very far away. So you have to scale everything else down in relation to that. Okay, so let's say 28 inches, or 71, let's say 71 centimeters, equals 5.91 times 10 to the ninth kilometers. So if you have an equation set down on a piece of paper, you have the distance of Pluto. It's 5.91 times 10 to the ninth kilometers. And that equals, let's say, 71 centimeters. Just say that. And then you're going to have to divide that by, let's say, the distance of, I don't know, whatever else you're looking for, Earth, 1.496 times 10 to the 8th kilometers. That's going to equal x in centimeters. And then you're going to have to cross multiply and then get it. So I just kind of told you how to do scaling. But so you will do that. Scale factor, 1 kilometer is equal to however many centimeters. Or 1 centimeter is equal to however many kilometers. It's fine. And you're going to get where every planet would be on that poster board from 1 to 28 inches. All right. And then it's kind of the same thing with part C. If the solar system were the size of a football field, 0 to 100 yards, every object in the solar system is going to be between 0 and 100 yards, and you'll have to figure out the scale factor for that as well. So, and then you'll answer the questions, and that's basically it. I mean, if you collab with your classmates over the next few days, you shouldn't have a problem with it. Submit the lab here by Saturday, and you'll be golden. So hope that helped a little bit. And you do not need a piece of poster board. You just need these dimensions, and I hope I made that slightly clearer for you. So, okay. Have a great break. Have a great week. And I will talk to y'all later.